welcome to another exciting adventure here at Blueglow Electronics. Today on the bench we have a Marantz Model 30, and I'm going to dig into this thing, find out what's wrong with it, and try to get it repaired for a customer. If you've seen, I've been doing a lot of Marantz gear. I'm guessing I've worked on 30 to 40 Marantz units this year, so it's been a pretty heavy Marantz year. I think a lot of it has to do with you just roll back the clock a few years, maybe 5, 6, 7 years. These things were they were popular, but they weren't kind of coveted or sought out as much as you see today. And you're starting to see a lot of these things surface, coming out of old closets and attics, and being picked up at yard sales and flea markets, and people are realizing they're really quality pieces of audio equipment and really wanting to get them fixed and restored and working properly. So at any rate, I'm going to throw the camera down, get the screws off the cabinet, and we'll dive into this thing. Alright, got the cover off, got it hooked up. I'll show you what I've done so far. Really all I have done is one, plug the power lead in, two, connected up my speaker wires, and three, running into the aux port. If you notice here, I'm just coming into a splitter, and this cable goes upwards to a B&K function generators. So turn it on. That's 1000. That's basically a 1 kilohertz sine wave tone. If I come back down here, turn the amp on, which I've got it on, I can hear noise out of one speaker. So if I go to the left, I hear it. I go to the right, and I have nothing. So we're basically dead on the right. I can hear it. It is ever so faint in the background. So something's wrong with the right channel in this thing. Come back up, we're good. I'm going to turn the volume down on it, and we'll dive into maybe what's wrong. This unit really just has a couple boards in it, and we're going to dive in and figure out what it is, and keep you posted as we go along. Alright, really all I've done, I'm just doing a little troubleshooting. I've done one thing. Got my handy dandy oscilloscope up here, lovely little unit, Tektronix 2246 100 megahertz scope, but there's some really neat functions of this scope that I love. But anyway, if you notice the little wire here, it's a ground wire. Comes down, connects to the chassis. Coming out of channel 2 here, which I've got active right now, and it's coming down, and I've connected it right here. This is where, let's see if we can show you a little better here. This wire here is what's feeding from the preamp into the output amplifier. And if you notice, coming out of it down at the end, there's a pink wire, a white wire, and then a wire in the middle that's grounded here to both this board and to the heatsink. So what you've got traveling from the preamp driver board really to the power output board here is a pair of wires that are somewhat shielded by this center wire. And so you got right channel and left channel over here. And if you notice, I've got it clipped right now on the left channel connection here. So really what we're watching here, and it's kind of hard to see, so I can get the trigger to lock a little more. This thing really tough. So I'll show you why the trigger's not locking so well too. What we've got going on, I've got this, you know, if you notice up here, as I shift the frequency on my counter, I'm actually getting the same input to this part of the amplifier. And I'm not going to worry about getting it to lock right now. There's another reason. There's a lot of noise on the actual signal itself. So not only do I have my 1 kilohertz sine wave here, but riding on top of it is a lot of noise. So it tells me a couple things are wrong. Well, one thing it tells me is good. My 1 kilohertz signal from the function generator coming into the aux ports on the back are making it all the way through the volume controls and whatnot, through the driver board, and making it to the output board. That's the good. The bad is it's got a lot of noise on it. A lot of hash is what I call it. And that hash is likely coming from this section right here, power supply, or potentially the bad power supply caps right here. At any rate, what I'm going to do is move this over to the other connection here, which is the right channel. And we come up here, and what do we see? We see a little of nothing. What that tells me is that most likely the output section itself is good. Somewhere up here in the driver board, this signal is dying, or it potentially could be somewhere along the audio path before you get to that, in the tone controls, balance, volume, or whatnot. But good news is the output here on the back of this amplifier is probably pretty good. A couple things I did notice though. When I took the cover off of this thing, there were 2 screws missing on the bottom. As I come along inside the amp, there is a screw missing right here. There's a screw missing right here. So, and I also noticed this pink wire right here. When I went to connect to it, it looked like it had been resoldered at some point in time. So I'm not the first person inside this amplifier. Let's just put it that way. All right, I'm gonna throw the camera down while I do a little bit more on the diagnostic side, try to figure out what's actually causing this, and we'll keep you posted as we go along. But hopefully you can see a little bit of the troubleshooting steps, kind of the logical approach. If you take any unit like this and kind of break it down into a block diagram of how things come into the amplifier, how things go out of the amplifier, you can then just start checking at points along the way and figure out exactly what might be wrong. So kind of a methodical approach. Once you get it down pat, it's really easy to use over and over and over. But we're going to see if we can figure out what's up now. We'll be back. Alright, a little bit more on the troubleshooting path. So I did something here. I disconnected the cable I had going up that was feeding the inputs on the back here. And what I've connected now is an RCA BNC cable up here to the function generator that comes down and basically has 2 test lead clips on it like this. And what I've done is I've connected the first one to ground, and if you'll notice when I connect in here, we have nice loud audio, and I can really drive that up with the little attenuator knob on the function generator. So that tells me the left channel and the power output is good. Now, let's come over here. Ta-da! And driving that really strong. So, what does that tell me at the end of the day? It basically tells me that the output section here is in good shape from a function standpoint. Now, I will say, if you noticed earlier, I said there was a lot of hash or noise on that signal. It's kind of hard to see in the video here, but I can see it on my scope. So what I'm going to do is basically troubleshoot this thing on through. I'm pretty confident now, based on what I just heard, that the output section here doesn't have any major flaws to it. So I'm going to leave it alone for now, and we're going to move up here into the driver section, some of the others. Once we figure that out, then at last I'm going to focus on the power supply section and kind of trying to get rid of the hash that's in here. But yeah, I just wanted you to understand a little bit of how you can kind of isolate these things into a block diagram. I may try drawing that out for you here in just a minute on a piece of paper, just so you understand what I'm talking about. And we're back. Handy dandy notebooks I use like this. I usually throw a sticker on them. Usually I just put the dates in the beginning, and I just make notes as I'm working on stuff. So over here I was recapping a Scott 222C, and I just kind of, as I was taking caps out, I was marking down what was in it so I could order some others to replace them. Yes, I was working on a Marantz 2250B and HE01, HE02, which are BA312 audio transistor packs. I had to find an equivalent of that, which is NTE 1433. And I just usually write that kind of stuff down so that next time I come around and I'll say, hey, whoa, I was working on another 2250B, and what was that part number that I had to have? So, at any rate, let's come over here to the block diagram a little bit. And this is rudimentary. I just drew it in about 30 seconds. But it'll hold true for most any Marantz unit or any stereo receiver combo type unit. So just a little pretend this little block over here are your inputs. You got phono, auxiliary, tape, whatever feeds on the input. Then you come into a section of the amplifier. First we were talking about all these connections on the back. Then you feed into a section that we would call, I would kind of call this block diagram being the volume tone selector section of the amplifier. So kind of the things tied in with this, all these various controls on the front. And if you'll see, there's usually a board here like this one that controls all the tone and selector, as well as kind of the mono in and out switch. Over here you've got the main speaker and secondary speaker switch, as well as count the headphone jack in on that. Sometimes headphone jacks can play interesting roles in amplifiers, and I'll show you why. The headphone jack is part of this section here, but it's also designed that when you plug the headphones in, to kill the circuitry from going anywhere, to the latter part of the amplifier. It kind of makes it to the preamp, but no further. And so if you ever have a bad headphone jack and you can't get something on the output, that might be one place to check. But you should kind of leave, the signal kind of leaves, I'm just talking about the signal flow. Kind of leaves this section here, the volume tone selector section, and it makes a couple paths. One, if the unit has a phono section, and you plugged it into the phono over here, and you turn the dial on the front here over to phono, then basically what happens is it takes a bypass and it goes through a second little board, a separate little board here, just designed to raise the extremely low signal coming out of the phono section. I'll give you an example. Typical phono signal is about 5 millivolts, thereabouts, maybe 3, maybe 5 millivolts on a moving magnet cartridge, so fairly small. What would feed into the preamp if you didn't go through the phono? Let's say you plugged it into the auxiliary port here, and you went into the section on the front and flipped it over to auxiliary. The signal coming through here is considered line level, and line level is somewhere around 1/2 volt. So to the order of magnitude 5 millivolts to 1/2 volt, you're orders of magnitude different there. That this thing has to provide some 10x amplification or so, maybe even 100x to get you into this section. Similarly, if you happen to flip to volume, if you happen to flip the selector to FM, what it does is really not taking any inputs from the back here. It's really taking your input from FM, which is probably getting an input from an antenna feed, but it's deciphering the FM signal and basically then sending it to the preamp. Once it gets to the preamp, usually there's not a lot of controls on the preamp. These things just basically take the signal from the level it's at and do some buffering, kind of quality of signal type stuff here, and then gets it prepped for the amplifier circuits. And in the case of this board, these two are combined on one board together. But in a lot of Marantz units, you'll see this mounted on the left-hand side of the chassis and this amp mounted on the right-hand side of the chassis. And I forgot to draw a few lines, like from here to here and here to here. So what happens then, the signal, when it leaves the amps, 2 amp sections, basically in the form of a speaker cable connection, which goes to the output, which you listen to. And one other part, you'll notice, kind of independent from all of that, all these boards, for the most part, even some of this part, requires power to drive the transistors and the circuits involved in the amplification or whatnot. So the power supply kind of has this dotted line, you'll see, to all these other sections. So if your power supply is not healthy, guess what? You can feel it all through the amp, and that's what we got going. Some of going on with this one. We got a little bit of hash on it right now, coming from the power supply section. It's not 100% clean, but I'd rather get the amplifier working first and then solve the noise. It's kind of one of those. Rather do the major surgery and let the patient get fairly healed up, and then we'll worry about the minor surgery per se. But I thought I'd show you this. One other thing you'll see on a lot of Marantz units is between this section and this section here, they will take these two wires and they will take them to the back of the chassis, and they'll basically cut them, snip, right? So if you open those two up, let me pause a second. All right, did a little bit of handy-dandy modifying here, but if you basically took these two things and ran them out to a jack on the back of each, that were just, left open, what would happen is the signal would never go from here to here or here to here. And what you could do is you could feed out this left little connection here, maybe over to another amplifier. So use the input part of this, but then maybe feed to a great big amplifier somewhere else. Similarly on this side, if you didn't jumper this, brought it over here, took it out to another amplifier, you'd be using the front end of this unit to feed another amplifier. Another thing you could do is, wow, what if this is a really nice amplifier section, but you got a different input you want to feed in than this. Maybe you want to use a preamp you have, maybe a tube preamp or a tube phono amp or something you have. You could actually feed it in on the other side here into this amplifier and out through the outputs, and just use this part of the amplifier. And what you see on the back then are these little bitty jumpers, about this long, 2 RCA jacks, and they plug in and snap, and basically completes the connection. So if you see those on the back of the Marantz unit, this one doesn't actually have them, but if you see them on the back of the Marantz unit, you'll know that's what it's doing. It's completing the circuit between the preamp and the amplifier outputs. And when those are missing, you may be missing your output audio, or you could use those, like I said, intentionally remove them and use them for other purposes. But thought I'd show all that to you real quick from a block diagram standpoint. So where we're at right now is basically, I jumpered, if you remember that pink wire and that white wire, well, that was these two wires here feeding these two right here. And so what I've done is basically tagged on right here and sent an audio signal here, and I tagged on right here and I sent an audio signal through here, and we got output from this amplifier. I may try breaking these and just see what kind of quality I'm getting from the output, but as right now what I know is I'm getting it out the left channel and not out the right channel. So I gotta go figure out what's wrong in here, because when you feed in the aux port, you're kind of coming through the volume and tone control straight into this. These aren't playing a role at all. So 99.9% chance this is the culprit for why we're not getting audio out of the right channel right now. Alright, a little more troubleshooting. If you notice up here on the function generator, this little knob right here is way at the very left, and I have it pulled out. When you pull it out, I don't know if you can see, but it's a, it says right below it here, pull for minus 20 dB attenuation. So with even the smallest signal I can put out of this function generator into the left-hand side of this driver board. So in other words, what I'm doing now at this point is I'm basically bypassing the circuit that we, if you remember in the picture we just drew through. What I'm done is I've came right here on these wires that are feeding the preamp, and on the left hand side I've now connected a jumper from my function generator, 1 kilohertz tone. And what that's going to do is provide me, it'll let me know, is my problem on this front end. Maybe it's part of this, maybe it's part of this, part of this. So what I've got it connected right here, and I'm getting a good clean signal all the way through on the left hand side of the amplifier. Let me swap it over to the right hand side and show you what I've got going on. Oh yeah, by the way, if I turn this volume up, nice clean sweep of sound, sounds really good. Volume increases kind of linearly per se, and it just makes a nice clean sound. So it tells me that channel, the left channel here. If you'll notice, this board is kind of, if you think of the front of the amp coming through, this half of the board is the left hand side of the amplifier, and it's kind of very symmetrical in design. This half of the board is the right hand channel. So we're going to swap over to the right hand channel real quick. Alright, move the little alligator jumpers from BNC to alligator connector up to the top. And if you'll notice, we don't hear anything. I can grab this knob up here now and start turning it up. You'll hear something, but even with it all the way on the right, it's barely there. So what it tells me is this section, this half of this part of the amplifier is what is bad. I have isolated, from this whole thing through a series of logic down to this little section just right here. Because what I proved was it wasn't anything on the front end causing my issue, because I basically removed that, and I still have, a major difference in feeding this side and feeding this side the output that I get. So, and think about the logic we've used here. We went from this entire whole unit, it could be anything inside of here, a lot of components, a lot of wires, all the way down to, let me unplug this, kill the power, and we'll flip it over. So what we've done now is basically this little square section right here is where my problem lies. So what I'm going to do next is basically, just because this amp's a friend of mine and I like the guy a whole lot, I'm going to take and replace each one of these capacitors right here, and I'm going to do it across the whole board. And I'm going to check these transistors. There's 3 of them over here, and I bet $50 right now that the problem will be solved. It's likely one of these transistors that are weak causing the issue, or it could be one of these capacitors starting to leak and short, and basically instead of sending the signal through the amplifier, it's starting to drain it off to ground. It could be one of these resistors, but chances are not. Certainly go through a series of logic of capacitors, the transistors. The capacitors, here's the deal. You could pull these and test them, okay? And use a handy dandy little capacitor tester that I have. The gig is, it isn't worth it. If you're going to pull it, replace it. If you're going to pull it, replace it. I mean, you can buy these things in bulk. They're fairly inexpensive. So by the time you pull these out, you might as well just put new ones in there. And if you're going to do half a board, another 15-20 minutes, why not go ahead and do the other half of the board? And then you can say this entire driver board has been rebuilt and will last for years to come. These transistors, a little different story. Not quite as cheap, not quite as easy to find in bulk. So I will pull each one of these, use a transistor tester. I will check them out. And if they work, I'll put it right back in here. I won't throw it away, I won't replace it, no need to. Because unlike capacitors, these are an electrochemical device is what I would call them. Think of a 9-volt or a D-size, C-size battery. Inside of those, if you've ever seen, it's a chemical and a physical, kind of a physics reaction that takes place, because there's things inside of it that basically over time will deteriorate and need replacing. So what you got inside of a capacitor actually is a long, if you think of go grab a roll of aluminum foil and lay it out, and then paint something on one side of that roll of aluminum foil once you rolled it out, so that that side's kind of insulated. And sometimes that thing that you paint it with may be a chemical that is that doesn't dry, it stays wet. And then you roll that thing up, and so basically you've created a capacitor, and lots of videos out there on what makes capacitors, but that's what's inside of these, a little bitty rolled up, typically an aluminum layer with some paste in between it, and over time the paste just dries out. Unlike these transistors, they really don't, age is not a factor in whether they're good or not. So putting those back in there will be certainly fine. All right, we're going to get busy doing that, and then once we get that working, hopefully we'll show you here in just a little bit. Then we'll move on to getting rid of the hash, which we'll get into the power supply section shortly. But just stop and think a little bit about how powerful it is what we just did. We removed this board from question, this board from question, this board here from question, you know, the whole amplifier output section from question. And we've narrowed it down to this little bitty section here that we're now going to focus on. All right, thought I'd show you another tip or trick or two here. This is a first capacitor I removed. Came out of this little bitty set of holes right here. You can see it is a 3.3 microfarad at 25 volts, and that's kind of hard to see here, but if you could read it, you could see that. And I keep bins over in the other room, but you'll notice these are radioelectrolytic capacitors. These are 35 to 100 volts, and in this bin I keep radioelectrolytic capacitors 0 to 34 volts. So in there I've got lots of capacitors, you know, in various bags and sizes. Some of these in kits, but yeah, I thought about, you know, I could come over here in this bag side and grab the exact same thing, 0 to 25 volts. 3.3 microfarad, and it would actually be some in this kit. That's where those would come from. But what I decided to do instead is come over here in the other bag and reach down in here, and what did I find? Some 3.3 microfarad. These are 50 volt instead of the 25 volt. But if you'll notice, due to the age of these capacitors, and these are new capacitors, these are the same size as these. So typically, years ago, if this would have been a 50 volt capacitor, it would have been a whole lot bigger. But stuff's just gotten so much smaller and more efficient these days. So I'm going to put the 50 volt capacitors in here, and here's why. They will just last longer. A little heavier duty in construction. You know, it's kind of one of those over-engineering kind of thoughts in my mind. And these don't really cost any more than the 25 volt ones. They might be just slightly larger in size, but not really in this case. So that's what I'm going to put in here. I'm going to use some of the Sanyo brand 2.3 microfarad 50 volt capacitors in this unit. Alright, I've replaced this capacitor, and after I did that, guess what I did? Because I want to know. I turned the unit on. Did not work. I replaced this capacitor. Turned the unit on. Did not work. So I'm going to keep going through it. I just wanted you to know that if it's feasible and time allowing, I will try putting a part in, testing, putting a part in, testing. Just because at the end of the day, I want to know what was wrong. Sometimes you can do what they call a shotgun approach. Hey, I just replace everything here and turn it on, and whoa, it works. And then really don't know what failed. It's kind of a shotgun approach, but I'm going to keep going through it methodically like this. I want to know the part that's actually causing this. Alright, at this point I have replaced this capacitor, this one, this one, this one, this one, and this one. It's basically everything on half the board here, and we still don't have audio. Now, my hunch all along would have been it was one of these transistors, and the reason I didn't go there first was I wanted to replace these capacitors anyway. If one of these transistors has failed, it could likely be the result of one of these capacitors shorting to ground or being leaky and actually causing one of these transistors to fail. So it was kind of just an approach I wanted to take. I wanted to replace the caps anyway, and now we're going to get to the actual transistors, pull those out and check them, and I'll show you that as I do it. And we have the first transistor out. Like I say, there's 3 of them there. Got the first one out. Not quite as easy as getting 2-prong devices out. Usually use a solder sucker on the other side to get rid of the solder on all 3 leads, and then you kind of use your iron, go back and forth, keep all 3 of them a little hot while you wiggle this thing out. But what I want to show you was this little device from a company called Peak Electronic Designs, and they sell this thing here. called an Atlas DCA. And what it is a semiconductor component analyzer. And right below that, if you'll read here, is the cool part, automatic lead identification. So really all you do at the end of the day is connect these 3 leads up, and I'll show you that here in a second, and hit the on button, and it automatically figures out which lead is the emitter, which is the base, which is the collector, and it presents you results back over here. These little units, give or take $10, cost $100, maybe 90, maybe 100, 105, depending on where you find it. Same company makes some other neat little units. The Atlas ESR, which I use all the time. Connect a capacitor to this, and it comes back, and what it tells you is the equivalent ESR, equivalent series resistance. So it's basically telling you whether the capacitor is good or not. I won't get into the function of how. I may make another video on that one day. But it tells you if the capacitor is good or not. It tells you the value of it. And then another device that Atlas makes here is the LCR, inductor capacitance resistance meter. So this is an active passive, automatic passive component analyzer. So you can take any passive component, whether it's an inductor, a capacitor, a resistor, throw it on this thing. First thing it will do is it will identify the item, what it is, and then second it will tell you its value. In microhenries, maybe if it's an inductor, or microfarads if it's a capacitor, or in ohms if it's a resistor. But anyway, enough about that. Each of these things 90 to $100, and well worth having in your set. Let me hook this up and show you real quick. So what I've done is just grab that device, and I grabbed any lead and I threw it anywhere I wanted on here. Didn't matter which connection I made, I just connected it. And let me show you how much of a time saver that is. So prior to this automatic lead identification, I would have had to came and looked up a device in a catalog, like an NTE catalog, and or this is a Fairchild spec sheet. But I would have had to find the device, so I had to figure out what that device actually was, first off. I had to go back to the schematic, find the device. I had to look it up in a manual here. Then I had to find the picture of it, and I'd have to say, okay, emitter, base, collector, so I knew where the pins went. And then I'd have to go back to a device, and each one would be labeled emitter, base, collector, and I'd have to connect it on there. And you're talking 4 or 5 minutes to do that, whereas with this new device, you simply just connect it up. And let me show you what happens here. We'll turn it on, so you can read it. It's analyzing. And it came back and told me it is an NPN silicon transistor. And then you can scroll down. It told me red was the base, green was the emitter, blue was the collector. It told me the current HFE gain. It told me the test current this thing used. It told me the emitter voltage. It's basically telling you all the voltages and currents between each of the junctions on this transistor. Told me how much leakage current was there, which is none, which is good. And that's it. So hold down the power button here, turn it off, and that's a good transistor. I'm going to put it back in the unit. I just wanted to show you something here. If you'll notice down here, these 3 connections in a row, those are where I took this transistor out. Unlike a 2-lead connection device, I can kind of grab a 2-lead device on the other side. I can unsolder one connection, unsolder the other, kind of wiggle it while I'm doing it, pull the device out. I stick a new device just into the hole and come around on the other side and get these hot and slide it through. Pretty simple. When you get down to having 3 holes here like this, though, it's not nearly as easy to put a 3-component device in. So what you end up having to do is use your handy dandy solder sucker here. Get the connection hot, put this on there, push the button on your solder sucker, which basically releases this little top part and pulls a vacuum. And what it does is it sucks solder up into the solder sucker. But you want to have 3 good open holes here like this, so that you can just slide that component in from the other side and then come over here and solder it up. Otherwise you will spend a lot of time trying to wiggle a 3-component device in here if you don't have those holes nice and clean. Just thought I'd show you that tip. Alright, still haven't found the failed component yet, but I want to show you something. Two of these devices I pulled out, if you can read on, they say C458. And you almost always tell them because they got this little wedge kind of shape to them versus rounded. And if you'll notice here, I got a bag and it says 2SC458 replacement. And with a Fairchild KSC 1845. And if you'll notice, I got 100 of these things. The reason I keep these in such quantities, these transistors are notorious in Marantz units for causing noise. Not sure why, but the older they've gotten, or just maybe they were this way from the factory, they're noisy. Anytime I touch a Marantz piece of equipment and I come across one that says C, which is short for 2SC 458 on it, I put new ones in there. They're just a few bucks a piece and save you some noise issues down the road. Just wanted to show you that. We're going to put these new ones in and set these old ones aside. Alright, we have found the problem. Wasn't simple though, trivial. It wasn't easy to find. Let me show you why. I had both of these 2SC 458s that I had in the just previous little section out, and both of them tested good, but yet we still weren't getting audio. And I came back over here and looked, and there really wasn't any other components to test. So I thought, how did I miss something? So I came back over here, and what I did, let me show you. I've got this one hooked up. It is an NPN silicone transistor. As I scroll through, it tells you about which connections are which. Then I see the HFE current gain here. So this is basically beta, or the gain of the transistor. 179 is what we're seeing on this unit right here. Hang on one second. Alright, we're testing the other transistor. It is an NPN silicone transistor, which says it's good, works. Tells me which connections are which. But if you'll notice, the gain on this thing we're getting is 56. And so right there lies our problem. This transistor is good but very weak. And I don't know if you remember, in the very early part of the video, I told you if I cranked the volume all the way up, I could start to hear something. And sure enough, I can. So it's because of this transistor. Let me show you this. This thing's on right now. Alright, we've got it plugged up. If you'll notice the volume here, I'll turn it up a little bit more up here what I'm driving it with. But volume's working across. Turn it to the left, I get noise. Turn it to the right, I get noise. So this thing's fairly well balanced at this point in time, and we're getting signal out of both channels. So now that we've replaced, actually the one that was bad was this little one right here. So there's 3 transistors in this unit, one here, one here, one here. These back two are the 2SC 458s. If you notice on the other side how they're square and wedged, these Fairchild replacements are not. They're more TO92 style chest case. I'm going to go ahead and do the other side of this amplifier, one, because I hate 2SC 458s. I always like to replace them with the modern Fairchild. 2, I've already done, this side of the board. It won't take another 20 minutes to do that side of the board, and then this thing will be almost up to par. Let me tell you, it's hard to hear, probably through the phone, but I've got some 60 hertz or 120 hertz hum in on this thing, which tells me I've got either some bad capacitors here in this power supply section, or some of the larger power supply capacitors that provide power to the output have got issues. So we're going to finish the driver board and then get into the power supply, try to get rid of this little bit of hum, and this thing will be finished up. Alright, starting to diagnose the power supply section a little bit. First thing I wanted to do, I'm definitely going to replace the caps on the little power supply board up here, just because they seem to always need it. But what I'm more concerned about are these large capacitors in the unit. And what I want to do is test those. So I disconnected the lead from one side of this one, And so I connected one wire here, then I connected down here to my ESR. Turn it on. Alright, what this thing come back and told me is, first off, capacitance value is 2392, so 2400 microfarad, which is about right for that cap. And then it told me my ESR is 0.05 ohms, so the equivalent series resistance, basically the breakdown inside of this capacitor. How much DC resistance does it have per se? And that's a very small number, 0.05 ohms. So nothing to worry about on that capacitor. This is what I love about this. If you notice, if you'll move this thing to another device, moved it down, the leads down to the other capacitor, turned it on, and I get 0.03 ESR and 2250 microfarad. Still very valid in range for these caps. The reason I disconnected this one is because when I first hooked up the leads to it, it came back, and the answer it gave me for the capacitance value was in circuit / leaky. So what it was saying was the rest of the circuit connected to it was keeping it from being able to test properly. So I basically disconnected this from here, and I'll go back and solder that back in now that I know these two capacitors are in good shape. I just thought I'd show you what I get with that thing soldered back in. You can measure the ESR. This time it was able to measure the capacitance, believe it or not. Oh well, maybe it just wasn't fully discharged before. At any rate, beauty of these things, they can do in-circuit measurements, and won't get into how it does that. It uses some high frequency technology in here to do that, but we'll look at that another day. I'm going to dive into the power supply board on this thing. And if you can see, I'm basically just going to replace, I started pulling this capacitor. There's only 4 capacitors on this board. I'm going to go ahead and replace them all. If you'll notice, the one that came out was a 63 volt, 470 microfarad, pretty big capacitor. The one that is going in its place is a KMG, likely made by Nikon, and it's the same size and same shape. I don't have any higher voltage ones for this right now, but or otherwise I'd put in probably a 470 microfarad 100 volt. But we're going to get this put in. We're going to swap out these other 2 capacitors here and go from there. Okay, power supply is complete at this point, and I'm going to move on to doing the next phase, which is commonly known. Got my cell phone too close to the audio circuit there, and the phone sync is causing noise. Let me turn this thing off for a second. Anyway, we're going to bias the output amplifier, and typically that's done, remember, very symmetrical. This side would be the left half of the amplifier. This side would be the right half of the power amplifier. So you've got these 2 sets of 2 little potentiometers here, 2 little potentiometers here. And I'm going to take you over to the service manual and show you something. Alright, I went to Hi-Fi Engine and downloaded the service manual for this thing. Really easy to do. Just go to Google, type in Marantz 1030 space service manual, and it'll be one of the places that pops up. You'll have to create an account and register, but beyond that you can download all the free manuals you want. Anyway, where it says power amplifier adjustment here, it's really the bias. So what you're setting is the operating parameters around the output transistors, the amount of DC offset that they have, and also kind of controlling the gain around the transistors, kind of the cut in and cut out per se. So trying to adjust it so you don't have clipping basically, but we can get into that in another video, or there are lots of them out there. I was just going to show you here. It says connect a VTVM, and that's what they had back in the day when this was created, vacuum tube voltmeter, but today a modern digital voltmeter will work just fine. So you connect it across resistor R47 and adjust trimmer R729 until the meter reads 7.5 volts DC. Let's stop with that. We're going to go do that. Alright, it's kind of hard to see, but up in here, this white little resistor is the resistor it was talking about, R747. And if you kind of follow the leads off of it, it comes to two jumper points here. The jumper points aren't necessarily aligned directly with where the leads go in. If you follow them on the circuit board, and it's really hard to see here in this video, but you can bring it back to two leads here, two jumpers here on the end. And I've run those jumpers out, and let me turn this power on. And basically I'm running it over to my little voltmeter here. So once this thing stabilizes after being on a minute, you'll see it's stabilizing at about 5.3, 5.4 millivolts right now, right? So let me spin this thing around just a little bit here. Move the meter over here. Maybe you can see both at the same time. That won't work if I turn it sideways. At any rate, R729 is this little potentiometer right here that I'm going to. And then down here on the handy dandy meter, we're going to adjust this thing ever so slightly till we get to 7.5. So what we've just adjusted right here is this this pot. And really what this is the DC offset pot. Try to get into that maybe in another video. This one's getting fairly long now, so I'm not going to. But then you will remove the leads and basically do the exact same thing on the other half of the amplifier and adjust for R730. So we'll basically come over here on the other side, follow the trace from this resistor down. Let's see, it's not coming there, it's going right here. So if you notice, that lead comes off here, but the trace actually falls down and goes to this jumper point. And the same thing on this one, this lead right here goes to right about here. Hang on 1 second. I got the wrong lead. I'm going to have to straighten out my lead here. Hang on 1 second. Alright, got my lead straightened out. Got it connected on there. So it's basically the second one down and the third, fourth, fifth one down. Jumper point here. I come back over here and lo and behold, what do I have? If you notice, the number's negative, but that's okay. It's just because I got the leads reversed from what they should be. And I'll come up here to R30, get my little handy dandy screwdriver in it, and ever so slightly adjust this down. It's tough. This thing moves quickly. $7.5. We're going to leave it right there. All right, let me, took the screwdriver off and it changed. Sometimes just the pressure of your finger pushing on it will cause this to happen. Just the pressure of the screwdriver on the actual device. Take that off, 7.2. Let me tell you a secret. 7.7. If you ever can't get one of these to stabilize, as in it never will really lock in. In other words, this thing's floating around from 7.5 to 8.2 to 4.6 and back and forth and whatnot. Basically, what you've got going on is you've got some capacitors on the board here that are bad and leaky and causing you issues. This thing's settled out at 7.6. I'm going to leave it there. But just if you can't ever get this part right, you've got more wrong on this board than just the bias is off per se. I'll be right back. All right, back over here to this service manual. If you notice, next it tells you connect an oscilloscope across the speaker terminals. Apply an audio signal of 1 kilohertz to the aux jacks and increase the audio signal till the audio output scope on the scope begins to clip. Adjust R723 for equal and symmetrical clipping. For the other channel, adjust R724. So basically one pot for one channel, one pot for the other. And I'll show you what we mean by this symmetrical clipping. Alright, here's what we have done. Taking the green wire from the ground on my oscilloscope down here to, let me get it back here in the light so you can see it. to the center speaker terminal. So that's basically where the black wire of the speaker terminal goes, right here. And then the actual oscilloscope probe I've connected to the right speaker terminal. And you know, I like using the green wire back up to the chassis of the oscilloscope. A lot of times they'll have a little ground wire clip right here that you can then clip down coming off the probe. I'm a bigger fan of this approach. At any rate, got an oscilloscope hooked up to the outputs, ground to the ground, and the probe to the hot lead. And if we come over here, I'm still feeding the input with a 1 kilohertz tone. And if you'll notice, as I start to turn the volume up on this thing, on my oscilloscope, I start getting my waveform. However, this gets very loud, so I'm going to reach over here on my little input device. This is actually my, let me turn this down. It is my BNC switch. So basically, coming out of the back of the stereo, these leads here feed up into the back of this unit. And inside there's two big resistors, 250 watt, 1% Dale resistors, 8 ohm. And there's one per channel. And then I come off of the leads of those resistors, basically what would be the speaker terminals, and I'm feeding this BNC output. So I can take lots of stuff from here and, for example, feed it over to here to channel 1 so I can watch it or whatnot. Or I can go up to Spectrum Analyzer, down to the HP8903 audio analyzer. I could go over to the Tektronix frequency counter. I've got a HP AA501A audio analyzer. I've got a scope. But all this stuff can get fed via the BNC connections coming off of this. Right now I don't have a lot connected to it, but on one end you'll notice right now I'm coming out of the back of this and I'm actually going up to a pair of speakers up here. They are just a set of bookshelf JBL 2600s. So what I'm going to do, if you'll listen, it's loud. I'm going to flip these two switches, right channel, left channel, and we no longer hear noise. So I can do audio work, and I'm actually feeding the power into those resistors instead of the output to the speakers. So it doesn't kill my ears while I'm doing audio work. Let me crank the volume knob down here just so you'll know what I'm doing. And let's watch. Let me see if I can get a steadier hand here on the oscilloscope. Watch what starts happening here. If you notice, it rises, it rises, it rises, and at some point, you should watch the very bottom, right down here of this. You'll notice it starts clipping. And if you'll notice right here, it's clipping on the bottom. It's flattened a little bit, but yet the top is still very, very round as it should be. And as I continue to crank the volume, it just gets worse and worse and worse. Finally, the top starts clipping. But in the video, if you'll remember, what it said was connect to the speaker output terminals and get it to the point that it's symmetrical. So what we're going to want is the top and the bottom to start clipping at the exact same time. And you achieve that by adjusting R723 and R724. Basically, you're adjusting the the balance, I would say, of the output transformers and how they're being fed, the bias per se. Kind of trying to find the middle spot, the quiescent spot, where both the up signal and the down signal are balanced and equal. Right now, with where this thing's sitting, they're not balanced and equal. The bottom half of the signal is a little stronger than the top half of the signal. So what I'm going to do is just start turning this thing, and if you'll notice, the bottom starts going away and the top is still good. So I'll crank it up a little more, and I'm starting to get some flat topping. If you'll notice, it still hasn't started on the top, so I'm still not where I need to be. I'll adjust it till it's gone there, and I'll keep cranking the knob here. Whoa, if you'll notice, they are starting at the exact same time to clip now. So we have symmetrical clipping on this side of the amplifier, but the top half, positive part of the cycle and the negative part of the cycle are equal. What you actually got here is, if you can see down inside here, yeah, right in here, you've got two transistors on each side of the channel, and they're in a push-pull configuration. So one transistor is actually what's amplifying the top half of the signal. The bottom transistor, the other transistor, is actually what's amplifying the bottom half of the signal. So what you're doing is you're making sure you're applying the same gain and the same voltage parameters around the transistor that enable them to produce exactly the same output given the exact same input, which is what we have up here. I'm going to disconnect for a minute on the video, connect to the other side, and come back and show you how we adjust that one. And we're back. If you notice, I moved the lead over to the other side here. It was on this side, and I moved it over here to this output. And up here on the scope, if you'll notice, and it's a little hard to see, the top half is pretty much perfect. The bottom is starting to clip right here, just ever so slightly more than the top half. So what we're going to do is grab that potentiometer right here, R724, and adjust it until that bottom peak is gone, and we're getting it on the top side now. So I'm going to kind of take it right here in the middle to where we've got it balanced, so both of them are starting together. Oh, that's just about perfect. We've got them balanced symmetrical. And you can now consider the outputs of this amplifier biased. So you hear the words a lot, oh, I need to get my amplifier biased, and you really don't know what those words mean. You just, it seems magical and something only a high-end engineer tech could do. But I have walked you through the procedure. It's not that complicated. You do need some pretty decent test gear, you know, a decent scope, some connections or whatnot, but it's not rocket science, I'll tell you that much. Alright, I'm going to hook this thing up and see how it's sounding, and maybe check distortion, a few things like that on it. Alright, we're going to bring this video home and kind of wrap it up. So after rebuilding the power supply, rebuilding the preamp board, and rebiasing the unit, she's sounding really good. Got my little iPod Nano hooked up to it here, playing some music. I got some songs that I always play every time on an amplifier because I know what the song's supposed to sound like, know where the highs are supposed to be, the lows. Anyway, unit's sounding really good. There's one or two more things I want to do to this unit before I get done, and let me show you what they are. I'm not going to drag you through the pain of watching it. This is the power cord on this unit, and yeah, you don't want to grab a hold of that. That's just flat out dangerous. So gonna fix the power cord for it or replace it on this unit, and that's really it. I'm going to take a second to explain why I took the time today to do this video. A couple of reasons. One, I really enjoy doing them. I enjoy imparting wisdom on others. Love getting others to get a laugh out of what I do, because I'm sure part of it's pretty comical. I've got a pretty southern voice here, living deep in North Carolina, so I get some comments on my southern drawl. But mostly because the guy that owns this thing, a friend of mine, lives over in Winston-Salem, and he asked me one day, he said, hey, you know, I'm interested in electronics, interested in learning more, interested in maybe doing some of what you do down the road. He says, is there any way I could come sit at your house and watch you work on something sometime? And I thought about it for a second, and my answer was kind of, not the best idea. And the reason being, there's just a lot of trial and error. I've got about 4 hours right now in making this video. There's a lot you didn't see where I was trying things and just kind of kicked those ideas out and started over or whatnot. But you know, it's one of those things. I did it so that he could per se sit beside me and watch what I did via YouTube, if that makes sense. I'm always interested in sharing my wisdom and knowledge on these things with others. I'm very interested in others getting in the hobby. I have no desire to hoard knowledge. Anybody that want to learn how to work on stuff and do it safely and repair their own gear, I would certainly be up for teaching them. that's why I'm making these videos. So we're going to go ahead and call this a wrap. And the power cord is pretty simple repair. I'll either fix that one on the end, which is doubtful. I'll probably just end up replacing the entire power cord with a different one. But at any rate, I wanted you to know what went on and see this thing through from beginning to end. Kind of went through the block diagram, and hopefully you learned something along the way. So, guys, stay tuned. We'll have more videos coming, and we'll continue to have fun. Thanks a lot for watching, and continue to make comments. I really enjoy hearing what people think about what I'm doing. Everybody have a great weekend.